Hey everyone. This week we're going to be talking all about genetic privacy. And so the primary speakers for the week are Sydney Partington, Bria Walker, and Lindsay Farr. Okay, so for paper one, it was called Attacks on Genetic Privacy via Uploads to Genealogical Databases. And so pretty much the central claim is that the DTC, or direct-to-consumer genetic services, are becoming increasingly popular. These services allow users to upload genetic information to search for relatives or others that share the same genetic genome. And so the database uses this genetic signal, or the IBD, which means identity by descent. And so this identifies pairs of people who share a common ancestor in the recent past, and that share the same segment of genetic material and result in sharing of a near identical stretch of chromosome. And so for this paper, the researchers actually looked at the IBS, or the identical by state segments, which are identical sequences shared among individuals that are thought to be a superset of the true IBD segments. And so when users upload this data, these services will provide information to customers about their shared IBS with each relative, possibly including number, lengths, and locations of the shared genetic segments. So without even realizing it, users' information is shared with a number of others, compromising the privacy of many customers. And so there are three methods that the researchers use to reveal the genotypes of users, which is the IBS tiling, the IBS probing, and the IBS baiting. And so IBS tiling involves uploading many real genotypes in order to identify genotype information from many regions and many people. And so pretty much this means that a user can upload multiple genotypes, including genotypes that are in the public domain, rather than uploading just the entire thing. And so for each IBS segment that is reported, the adversary gains a small amount of genetic information about a target genome in the database. Through this method, it is possible to obtain large amounts of genetic information. And so this is figure one on the right. And so the green lines represent the multiple genotypes that are uploaded, and the positions at which the IBS are in blue. And so once enough data sets are uploaded, the target will have a lot of their genome tiled. Okay, so this is also figure two, and IBS tiling is also shown in this figure. So this figure shows the median amount of coverage that is obtained by IBS tiling as a function of comparison sample size. So in the top left, it shows the IBS, it shows the average coverage across each of the person's two haplotypes. And then on the top right, it shows the IBS2 coverage, or the length of the genome where both haplotypes are covered by IBS tiles. In the bottom left, it shows the IBS1 coverage, or the length of the genome where exactly one haplotype is covered by IBS tiles. And then on the bottom right, it shows the length of the genome covered by either IBS1 or IBS2. Okay, so IBS probing, it allows the adversary to learn if the target's genome contains a specific disease allele. It allows one to identify people with specific genotypes of interest. This method is an application of the same idea underlying the IBS tiling that we just talked about. And so this is done by extracting a haplotype that surrounds the allele of interest and placing it into a false genetic data set, which is designed to have no long IBS segments with any real genomes. So if any relatives are found, it matches the allele of interest, revealing that they carry this allele. So this is different from IBS tiling in that it recovers genetic information from across the genome, whereas IBS probing only acts on a single locus of interest. So there's an advantage to this, which is that IBS probing is possible to do even in databases that do not report the chromosomal locations of the segments. And so figure three shows IBS probing, which is on the right of the slide, on a chromosome in a certain position. And so as you can see, it gives the proportion of haplotypes among the sample size that is covered at the chromosomal location. And so there were no matches outside of the specified location, which is like the flatter parts, indicating that there only was a match at the point at where it peaks. And so there are two factors that affect the efficacy of IBS probing, and it's the minimum IBS match length and the frequency of the allele of interest. Okay, so then the third is IBS baiting, and this one involves uploading like fake data sets with long runs of heterozygosity to induce phase-unaware methods for IBS calling to reveal genotypes. And this method can only be used if the database identifies putative IBS segments by searching for long regions where a pair of people have no incompatible homozygous sites. And so the main tool that is used in the construction of these fake IBS segments is by assigning every uploaded site in the region to be heterozygous. And so these runs will be identified as IBS with every genome in the database using the phase unaware methods. And so there are actually two ways to do this to identify the runs, which is the single site IBS baiting and then the parallel IBS baiting. Okay, and so the single site baiting is the simpler method out of the two that is used to reveal the genotypes. And so figure 4 actually explains this process and shows that 2 uploads are required, each with runs of heterozygous genotypes flanking at the key site. And so at this site, the 2 uploaded data sets are homozygous for different alleles. And so you can see it says no breaks in figure A. So if there is a break with either upload, the target is homozygous for the allele not carried by the upload that shows the break. And if there is no break, the target is heterozygous at the site. Okay, and so on the other hand, parallel IBS baiting allows the user's genotype at hundreds and thousands of sites across the genome to be identified by comparison with each pair of artificial genotype. And so there actually is a procedure to detect these genes that starts by designing a single pair of uploaded files as it follows. Okay, so the first step is to identify a set of key sites to be revealed by the IBS baiting procedure. And so for every key site, the sum of the distances to the nearest neighboring key site on each site must be at least the minimum IBS length reported by the database. Okay, so then the second step is to produce 2 artificial genetic data sets. And in each, every non-key site is heterozygous. Okay, in one, each key site is homozygous for the major allele, and then the other, each key site is homozygous for the minor allele. Okay, so then the third step is to upload each artificial data set and compare them to a target user. The key sites that are covered by the putative IBS segments between the target and both artificial data sets are heterozygous. And then the homozygous target for the major allelic key sites are covered by putative IBS segments between the target and major allele homozygous data set only. This procedure will reveal the target's genotype at every single key site. Okay, so then the conclusion. So we learned that there are many different methods where a user can learn the genotypes of the people included in the genetic database. And so privacy breaches by IBS tiling, IBS probing, and IBS baiting is common, but it can be prevented. And so I have a few questions for the secondaries. Which factor do you think is more important in terms of the efficacy of IBS probing and why? And then in what ways do you think privacy breaches from DTC genetic services can be prevented?
Before going into the questions, I actually just
Yeah.
had a question in general.
Yeah.
I was wondering if you had any examples of these databases. So are these just being created by researchers individually, or if it's like publicly available databases?
They're like publicly available, like 23andMe or like ancestry.com, any of that stuff.
Okay, and do you know like what, I don't know if you know this, but do you know what credentials are needed to access the database, or like how generally like researchers are able to get their hands on the raw data?
Honestly, it didn't say anything in the paper. So this is just me like taking a guess, but I'm pretty sure if you just like do like the services and upload your results, anybody can access this information.
Okay, thank you.
Also in paper 3, I'll go in to discuss that question a little bit more.
So I guess if nobody has anything else, you can go ahead and move on to paper 2.
Okay, paper 2 was called How Lucky Was the Case, or the Genetic Investigation in the Golden State Killer Case. And this paper discussed the Golden State Killer case and how the genetic investigation enabled law enforcement to find Joseph DeAngelo, which was a serial killer and rapist. And the paper claimed that with the arrival and rapid growth of the use of SNP databases, genealogical and genetic information can lead law enforcement to suspects, but at the same time can lead people to very distant relatives that they have never met. In this case, investigators had hit a wall with CODIS, which is the database that they use in law enforcement investigations a lot of the times. And so they turned to the GED Match S&P database, and the paper discusses the effectiveness of this method as well as the phenomena associated with the method, which are genealogical blowup and the noisiness of genetic inheritance. So this is figure 1, and it shows how rapidly the use of S&P databases have increased in the last few years, which can be helpful to investigations, but can also be seen as a breach of genetic identity of relatives to the people that are being investigated. And like I said earlier, the investigators in the DeAngelo case used GED Match to identify him. Genealogical blowup is the phenomenon that states that the number of relatives that one has at a specific degree of relatedness increases as relatedness becomes more distant. For example, I have 1 sister, 10 first cousins, and 22 second cousins, and I'm much more closely related to my sister than my second cousins. But since there are so many, their information is more likely to be in the database than my sister's. So this is figure 3, and it depicts the genealogical blowup phenomenon. On the left side of the figure, it shows the probability that a random person has at least 1 cousin in a degree P in a database, which increases a lot as the first few degrees increase, and it kind of becomes stagnant past the 3rd degree of relatedness. And on the right, it shows the average number of cousins that are contained in a database. The second phenomenon discussed in the paper was the noisiness of genetic inheritance. And it states that usually a person has many distant cousins, but the amount of shared genetic material is limited, which causes noisiness. Figure 4 is on the bottom left, and it shows the ability to identify shared DNA from a grandmother between first cousins, which is identical by descent. And if you compare that to figure 5, which shows the difficulty in finding overlap between third cousins, there's much more overlap that is identical by descent in first cousins than there are in third cousins. And the appreciation of this phenomena can help to develop the use of the method by law enforcement in the future. And one has hundreds of genealogical eighth cousins, but those are very hard to identify because they're most likely not going to be genetic cousins. And identifying first cousins of a suspect in a database is very easy, but the likelihood of their information being in a database is very, very low. Figure 7 depicts the degree P of cousins, which one expects to share at least one genetic block with. And as you can see, there's a sharp decrease as the degree of relatedness increases. And if one shares one genetic block, there's not going to be much that leads identification. But if you have 3 or more shared genetic blocks, that can be considered a sharp lead. Figure 8 depicts the optimization in these phenomena. And as you can see in the 3rd through 5th cousin range is where this optimization occurs. And that is because there are many genealogical cousins at these degrees of relatedness. And a lot of them are detectable genetic cousins, which means they're the most effective way to use this method because it will be easy to identify them. So law enforcement can most likely solve a case or identify a suspect by using a mixture of 2nd, 3rd, and 4th cousins. In terms of the effectiveness of GED match in suspect identification, in this case, it did prove to be effective in this case, and if the assumptions in the paper are followed, it is likely that many people will have at least one high confidence genetic cousin in GED match, but since they might not be a genetic cousin, it could be it could be difficult to identify them. The number of third and fourth cousins found for D'Angelo, which was 10 to 20, is not far from what they expected. Uploading of one's information onto a genetic matching database can open up many other people to identification, which can lead to ethical issues. CODIS is the method used by most law enforcement, and it only contains a sample from 13 million individuals, while GED match contains pretty much full genetic information of about 1 million, which makes identification much easier. In conclusion, for paper 2, the use of GED match proved to be very informative and very effective, but it might not always happen that way because it is very difficult to obtain all of the information needed to create a match, and there are many ethical ramifications of this method, so it's not legal in all states, so that makes it difficult for law enforcement officers to use this method. And in terms of questions, how do you think this method can be used without disrupting the genetic privacy of innocent, distant family members involved? And which phenomenon discussed in the paper is more important whenever it comes to genome mapping?
So to touch on the first question, I guess I've ever since I read this, I was thinking about like how you could ethically use this, because obviously it's super important and helpful for law enforcement officers to be able to use these kind of databases, especially when they have genetic information of a suspect. But I think in terms for it to be like, to protect the privacy of like distant family members, there might just have to be something put in like the terms of service or like the agreement that you have to sign or like consent to, I guess, when you use or upload your information to one of those databases. That's just like, if law enforcement wants to use this database to help try to solve a case, then like you are giving them your consent to use your genetic information or something like that, because otherwise I just don't think like the privacy of a lot of individuals would be violated. Because, you know, if you're just an innocent person who's never even met like the Golden State, like D'Angelo, now all of a sudden you're implicated with him, that comes with a lot of like moral weight and just like a lot of privacy issues. So I think just having something in like the terms of service or like an agreement that you just basically consent to law enforcement being able to access your genetic information would probably be the most effective way to do that.
Yeah, I agree 100%.
Just adding on to that, I would also say having law enforcement use the method as sort of like a last resort, given like the amount of contamination that can happen at crime scenes and cause like unfair or just incorrect like associations, like Cole said. Also just I know that there's not a way to do this, but like ideally using genetic information and genetic testing as just another piece of evidence rather than like an end all be all, given the fact that contamination can happen and incorrect matches can also occur.
Yeah, that's a really good point. I agree.
I also learned that a lot of these sites have terms and conditions on their website that kind of says, you know, if you're uploading your genetic data, you're consenting to there being a possibility that there's some unexpected usage of this. And a lot of, when this technique was on the rise, a lot of these websites kind of, you know, sent out an email or made an announcement that, hey, you know, law enforcement can use this data specifically for violent or person-on-person crimes. They really tried to avoid using it for things such as like paternity tests and like abandoned babies, finding the mothers of abandoned babies. But there still is the concern of, you know, an innocent family member coming up and having their genetic information given to law enforcement without their knowledge, because, you know, a lot of these third and second, fourth cousins, the person that uploaded it may not have any contact with them, and they'll never know that their DNA was uploaded to these websites. So I think it is really hard when it comes down to like the privacy concerns. And I think a lot of bioethicists can do some work in figuring out what is the most ethical way to go about this. So I think that discussing these papers opens up a great discussion to, you know, kind of figure out what the best method to do this stuff is.
Yeah, I think so too.
When touching on your second question, I think that the aspect of understanding the genealogical blow up was really, really important, especially since they caught the killer by looking at all of his 10 to 20 likely relatives that were more distant rather than closely related to him, if that makes sense.
Yeah, I agree. And that was something that I really I didn't know there was a difference between genealogical cousins and genetic cousins. And so that distinction I think is really important. All right, if there are no other questions or comments, we can move on to paper 3.
Awesome. Okay, so I had paper 3 and it was titled Using Genetic Genealogy Databases in Missing Persons Cases to Develop Suspect Leads in Violent Crime. So the direct-to-consumer genetic genealogy databases have been used to identify suspects in missing persons in over 50 cold cases. This was in 2019. And genealogists and law enforcement have worked together in this attempt to solve crimes in which their main source of evidence is raw DNA files uploaded to genealogy websites such as GEDmatch and Family Tree DNA. But there are some outstanding issues, as we were talking about before, relating to informed consent, as well as not all of the people in the databases having actively opted in to participate in law enforcement matching. So in this paper, the methods used to collect DNA evidence, the accuracy of this evidence, and concerns about privacy are discussed, and ethics, excuse me. And some of the evidence that comes up is forensics versus genetic genealogy autosomal DNA tests, the rise of GEDmatch, and privacy and security implications of this testing. So the first thing I'm going to discuss is forensics versus genetic genealogy autosomal DNA tests. So forensics DNA testing primarily uses autosomal STRs, which are short tandem repeats, and the number of markers tested varies between jurisdictions, but current tests use between 16 and 23 autosomal STRs. And the UK National Database has profiles representing 8% of the population, while the FBI's SCOTUS databases had profiles representing 4% of the US population. And these tests are done on DNA microarray chips, which sample several hundred thousand autosomal SNPs scattered across the genome. And so this genetic genealogy market is dominated by 4 companies. The 4 companies are Ancestry DNA, which has now tested nearly 15 million people, 23andMe, which has tested over 10 million, MyHeritage, which has tested 2.5 million people, and the Family Tree DNA is reported to have an ancestry database of about 2 million people. So when law enforcement are using this DNA and solving crimes, they are required to get these samples retested on a forensics SNP chip. And these commercial autosomal DNA tests have been validated by millions of genealogists, but they have not been validated for forensic use. So it's important for them to go back and retest these samples to make sure that the accuracy of the data will work for the case. And then one concern about these commercial tests is that there is essentially no way to demonstrate that the DNA sample submitted for analysis is actually the person of interest. So there are a lot of concerns with using kind of this commercial uploading website to test for suspects in crime. So they're kind of trying to work through that and figure out what the best way to go about that would be. So this is figure 1 in the paper, and it goes into the website GED Match, which is a privately owned website run as a hobby by 2 genealogists, which provides a range of tools for analyzing and interpreting DNA and DNA matches and genealogy data. So in figure 1, you're able to see the range of sophisticated tools that can be used by its subscribers. And the data on this website represents a publicly available subset of the data from each of the commercial companies. And this database is not publicly available and requires a password protected account to view matches. So basically, it kind of is anybody can sign up and upload their data, but you need to be have an account with a password and all that. And there's also a subscription fee, which provides access to additional tools for advanced users, which is seen in figure 1. So yeah, that's figure 1. And so figure 2 in this paper is an example of the free one-to-many match tool that provides users with a list of the top matches in the database. There are many clickable options in this tool that provide users with further information. So as you can see in figure 2 here, the type refers to the type of kit uploaded to GED Match. So F2 is family tree DNA, ancestry or MyHeritage kit. V2, V3, and V4 are 23andMe kits. Clicking on the L will provide a list of the one-to-many matches for that person. Clicking on an A will give a one-to-one autosomal comparison showing the shared segments of DNA. And clicking on X will generate an X chromosome comparison. So figure 3 kind of just goes into more depth on the specific GED services that you can subscribe to. So this is the one-to-one autosomal comparison tool, which allows users to see how much DNA is shared between 2 people. And so the location of the shared segments on individual chromosomes and the number of SNPs in each segment is also shown using this feature. If a user opts into a public profile, they can click through and see the match list of the people that they match with, as well as if their profile is public. And many genealogists have shared their GED match kit numbers in Facebook groups in order to obtain large amount of data about other users. So just getting back into the privacy and security implications, which I think is something that's really important for this paper. So as was discussed in paper 2, GED Match was used by law enforcement agencies in the Golden State Killer case, which was a cause for security concern among many people. So this was the first time that we saw this rise in using these services, and people started to get freaked out a little bit, and the database was being used without the informed consent of the participants, and they were not notified of this usage by GED Match or law enforcement. And at the time, the GED Match site policy was broad enough to avoid any serious backlash, but they did update their site policies to warn users about unexpected use after this case. Something else is that the possibility of privacy breaches at GED Match is also a cause for concern. These breaches include denial of service attacks and the creation of synthetic relatives to corrupt the database and throw off investigations, which I think is absolutely crazy that someone would go through all of that trouble just to throw off investigations. But I mean, I guess it can happen. And something else is that genealogy hobbyists do not need to be professionally accredited in order to charge and provide work to individuals. And because of this, there are genealogists that charge for their services but produce poor quality work. And the work in cold case investigation is mostly conducted by volunteers. And these investigations are inherently risky because of the lack of accountability and the potential risk for leaks and information. So just kind of wrapping up my paper, the use of this genetic genealogy database in missing persons cases can prove to be extremely beneficial in providing suspect leads, but the multiple concerns surrounding GED Match and other consumer DNA databases complicate this process. Actually, in the UK, there has been ethical principles devised by the Biometric and Forensics Ethics Group, which provide a wonderful foundation for discussion on these concerns. I think that this is probably the best way to go about figuring out how this information can be used by law enforcement. So some questions that I think would be really interesting for the secondaries, or I'll post them on Piazza for everybody to talk about, is what is your opinion on this usage of genetic genealogy databases in missing persons cases? And what can law enforcement or bioethicists do to make these searches more ethical and provide its users with more security? So if any of the secondaries want to answer, that would be great, or any of the primaries if they want to add.
I can jump in regarding like the second question. I think even past law enforcement, I think companies like 23andMe and Ancestry could make their terms and conditions a little more readable, because generally it's just huge walls of text that people don't read and just accept, by like making it bullet points or something that's a little bit more easily accessible, and having the people who've already done it sign it again, and make the earlier things void to be used by researchers or law enforcement. I think that's sort of like the first step in gaining like a better informed consent for the data to be used by researchers, because like I do understand that the data is really important in terms of like collecting sites for genome-wide association studies or something like that, but I think it's also potentially really dangerous in terms of it being used by other parties such as law enforcement.
Yeah, I definitely agree. I think that, sort of changing the layout of the website and the terms of condition could be something that inform a lot more people about, kind of what they're submitting their data to and the possibilities of this data. And I think actually having something to sign, you're right, would get a lot more people's attention, hopefully. But again, there always is that issue of, having the third or fourth or fifth cousin that you've never met and don't have contact with, and they'll never know that their genetic information is online. So I think that is something else that is concerning, and it's kind of hard to think about how you would go about, either informing those people or just kind of making it more ethical. Because, I think it's very helpful in investigations. I mean, it helped catch the Golden State Killer, but at the same time, there were a lot of, family members that he had never met that had been affected by this and had their privacy interrupted, all of that stuff. So I think it is a really interesting discussion.
With your first question, I do think that with using missing persons cases, that it is very important. Like I remember the paper mentioning like the DNA Doe project, and they were able to find the identity of the one girl by locating her first cousin, which I know gave that family closure. So aside from all the ethical like issues that can arise, I feel like in missing persons cases, finding their identity is very, very important.
Yeah, I do definitely agree with you. I think that this is very helpful in missing persons cases. And, we didn't have this technology several years ago, and it's just amazing that it's kind of closing all these cold cases. And I think it's really important breakthrough in this forensics technology. So yeah.
To touch on the second question, it said in the paper that the raw genetic data was not disclosed to law enforcement agencies. So they were only able to see like the amount of DNA shared and the length of the shared segments in order to like infer the relationship of like relatedness between two individuals. So I think that's like a really important measure that they're taking. I also think like removing any markers that would be able to identify a person until like they're specifically requested could also like be important, especially for like third, fourth, fifth cousins where you're so distantly related that like you've likely never even met the person before. I think that could be important to someone's privacy, and just I think stuff like that would be really important. And then they also said that the site could be used to like predict like the propensity for various diseases,
Mhm.
although it's not like super accurate. And I don't know, like they can then use that to infer stuff about people. And that seems like a huge like breach of privacy, because I know like a lot of people just like ethically themselves might not either A, want to know their propensity for a disease, or B, want like other people to know about it.
Mhm. Yeah, I definitely agree. I think those are great points. I was very interested in reading that section of the paper because I know personally, I like that would be a huge breach of my privacy if I figured out that I had some sort of disease through this and I didn't really want to know. Um, and yeah, there was also a section where they talked about are your parents related? Which I thought was pretty interesting, you know, finding someone's parents and how if there's some sort of incest within the family, it can make it hard to identify people even further. So I think that is a huge breach of privacy too. Um, so yeah, I think removing the just kind of identifying markers until they have some sort of lead on the case is a great idea to kind of conceal people's privacy. So if there are no more questions or comments, I think that we are going to just say some final remarks and wrap up the presentation.
One thing that I kind of like learned about reading all of these is, and just connecting to other things I've seen, like even like I know Law and Order, like Special Victims Unit, I know that it's a show, but they actually talk about the ethical concerns of using like sources like these to locate relatives of the killer, to like, especially if they can't find that specific killer's DNA at the scene. Like I do remember like a lot of ethical concerns being spoke about. So it was really cool to tie that in with reading these papers as well.
Mhm. Yeah, I think definitely a lot of the crime CSI shows are definitely popular. So I think discussions like this always pique people's interest. And I know that I'm super duper interested in forensic science. That's what I want to do for a career. So when I saw that we were reading these papers on week 12, I just had to take the opportunity to, read through it and discuss it with everybody. So I think that all three of these papers tie into each other really well. We go from learning how the actual testing works to learning about a specific case which it was used, and then kind of going in more and in more depth about the specific consumer sites that are used to collect this data and sort of the ethical and privacy concerns. So I think we had a really great discussion. If any of the primaries want to add anything.
Yeah, I agree. I think it was really important to start out talking about the IBS tiling and stuff like that. And then we kind of got more narrow and then got more broad again to discuss exactly how investigations like that work and
Mhm.
how the databases work. And I think it was really important.
Honestly, I think like these three papers was a good pick. I think it has a good mix of, like doing the processes and doing the methods. But then it also provides you with like actual real life scenarios. So
Mhm.
it's not just straight, here's some facts, here's some data, here's what you would do, but more like here's how you do it. And here's an example of when we do it, which I thought was pretty cool.
Yeah, I definitely agree. I think learning about these kind of complex um, testing, I think that it's important to have, like a real life scenario tied in. I know that's how I learn the best. So I think kind of discussing the Golden State Killer and just other missing persons cases, I think it makes it easier for people to learn and kind of absorb this data and apply it to real life situations.
I agree.
All right, if there's no other questions or comments, I'm going to stop recording now. Thank you all for watching, and I hope you have a wonderful day.